Hi folks, we're going to take a look at page 208, number 11. So the question says the measure of one of the equal angles in an isosceles triangle. So I'm actually going to stop there. And again, as soon as I see anything that's physical, anything I can draw a diagram for, it's the first thing I'm going to do is I know I'm working with an isosceles triangle, because sometimes you might not see where something is going, but if you've got your picture right away, okay, it might help out. So here we have an isosceles triangle. So it says the measure of one of the equal angles. Okay, so we're talking about one of these angles, because these are the two that are equal, okay, is twice the measure of the remaining angle. So this angle is 2 times that angle. Okay, so in order to solve the problem, again, what I would normally do is now give variable names to the things that I'm either looking for or I have information about. Okay, so this is 2 times that. So if I call this angle x, that angle has to be 2x, and then this angle, because it's equal, is also 2x. Okay, so you see by having the diagram, it's just so much easier to just input information as I need it. Okay, now here we have information about the 3 angles in a triangle, and of course, the big piece of information we know about the angles is they add up to 180 degrees. But of course, here we don't want to work in degrees; we want to work in radians. Okay, and we have our relationship between radians and degrees, and we know that pi radians is exactly equal to 180 degrees. So instead of these adding up to 180, I'm going to say that x plus 2x plus 2x, the sum of the 3 angles, is equal to pi radians. Okay, and now from here I just solve the problem. So here we got 5x equals pi, so x is equal to pi over 5. So that means my 3 angles are equal to pi over 5. Okay, my angles are pi over 5, and then the 2 equal ones, which are just going to be twice that, 2 pi over 5 and 2 pi over 5. Okay, so just to recap, okay, set yourself up by drawing a diagram, then interpret the information that's given, and in this case here, we had to use our knowledge of the angles in a triangle, except use the new units of radians instead of degrees. Okay, that's it for this one.